Lastly, we're going to look at a problem similar to the beginning of this worksheet where you had a graph, but now you're not given a graph of the figure, you're given a set of points. So if you look right here, you'll notice you're given 3 sets of vertices, so that makes a triangle, and you're given the images of those points after dilation. And again, the purpose of this is to figure out the scale factor. And with this particular kind of problem, we're going to emphasize again the vertex method. So here's how this is going to work. And I know in the last video I said I was going to do all 3 points, and I didn't for the sake of time. But in this particular video, I will try to do all 3 sets of points. So the first set I'm going to look at will be K. How did K change to give me its image of K prime? So to do a little writing here, and you should write out the same stuff that I'm writing here on your paper as you follow along. I'm going to start with K, knowing that K, of course, was -1, 0, and it was dilated to K prime, which is -1.50. So the question becomes, if this was our original x and y, this is our new x and y, what did I multiply these numbers over here by to get these numbers? That's pretty much what we're trying to figure out. That's how we would determine the scale factor. Now we could simply just divide these numbers over here by these numbers and figure that out pretty quickly. If you want to do that because it sounds pretty easy to you and makes sense, then feel free to do it. I'm going to write an equation again to solve this problem. So again, I know that I took -1 and I multiplied it by this unknown scale factor, and that gave me -1.5. So if I want to solve this equation, I would just divide both sides by -1, and I get K is equal to 1.5. So according to just the x coordinates, the scale factor must have been 1.5. If I do the same thing, of course, with the zeros, I run into a problem because I can't divide by 0. So in this case, the y coordinates aren't going to do me any good. Okay, so right now my scale factor is 1.5. Now if I try the same thing again with the second set of ordered pairs, L to L prime, let's see if I get the same result. So L starts off as 2, 1. It gets dilated to L prime, which is 3, 1.5. And again, our original x and y values are here. These are our new x and y values. If I start with 2, 2 was multiplied by some scale factor to give us 3. So to figure out the scale factor, we're just going to divide both sides by 2, and we get K is equal to 1.5. Lo and behold, the same scale factor I got from before. Now, this time I do have some usable y values, so I could do the same thing. 1, the original y value, was multiplied by some scale factor to get 1.5. This one should be pretty simple. We just divide both sides by 1, and we get K is equal to 1.5. So again, you can see that no matter which set of ordered pairs I use, I get the same scale factor. And that kind of makes sense why I did not use all 3 points in the last example with the graph, because you're going to get the same result. And again, to verify that, I'm going to do the same thing again with our last set of ordered pairs. That would be M and M prime. So M was originally 2, -1. It was transformed to M prime and became 3, -1.5. Our original x and y are there, and our new x and y values are there. So original x, 2 was multiplied by some unknown scale factor to give us 3. That looks kind of familiar. I think we've already solved an equation just like this one. And again, we get K is equal to 1.5. All right, so again, we see 1.5, 1.5, 1.5. And then if we look at the y values, this one looks somewhat familiar as well. We multiply -1 by some scale factor K and get -1.5. To solve for K, we divide both sides by -1, and we get K is equal to positive 1.5. So you can see no matter which ordered pairs you pick from the group, you're going to get the same scale factor each time. So it's pretty much the reverse, I guess, of the vertex method. but very closely related. So we're going to still call this the vertex method. And that's how you do it. Feel free to watch this video as many times as you'd like until you get the hang of what we're doing, and continue to work on the rest of your worksheet. Thanks for watching.